Hello students, I am Dr. Tanmay Vishwas. I welcome you all in my channel Chemistry, the Mystery of Molecules. So today we will discuss a MCQ about decarboxylation process. It's a very unique MCQ. The molecule is little different. So this molecule undergo decarboxylation and produces a product. Question is, what is the structure of product? I have given 6 options, so you have to find out. As usual, I suggest you first you pause the video and try this by yourself. Later on I will definitely explain. So you have to find out. So please start. I believe you have tried this. So let me explain. So what is the purpose to give of this problem? See, this is a dicarboxylic acid and this undergo decarboxylation at 90 degree means pretty mild. Okay, and produces some product. We know that beta-keto acid undergo decarboxylation very facile way, and this is also a beta-keto acid, means 1,3-dicarboxylic acid. So it should follow the similar track way, but does it provide the exactly same product happens normally for this one malonic acid, means this and this, or not? So that is the question. So as usual, let me tell you the answer. It is not follows that question, and that is the main reason to select this problem. So it is not the product. So if these undergo normal decarboxylation, so we can expect that one carboxyl group will be eliminated and this hydrogen will come and this will be the product, but this is not the product. Okay. So actually the product is this. So I will explain how this is happening and how this ring opening happening. So this is not the product and this is also not. Okay, no double bond is formed and not none of this. So now I will explain how this is happening and why this. Okay, and another thing, keep it in mind, such type of cases generally this 1, 2, 3, 4, 5 lactonization for 1,5 is relatively easier. So generally it is expected, it will not. Question this, so ring open this not, that is. I will explain. I know this problem is little confusing and that's the main reason to choose, because generally some unique examples are chosen in the exam. Okay, so let me explain this thing step by step. So before going to details, I want to give you hints that please be careful about cyclopropane or cyclobutane, those things, mainly for cyclopropane, because cyclopropane is a very unique molecule. Unique molecule means it shows many cases some unambiguous properties. Why? Because this cyclopropane is a 3-member ring strain, and so it has a chance, very chance, that it breaks, and that is the reason I believe this molecule broken and resulted in the formation of this lactone derivative. Did I wrote the right? Yes, I wrote the right. Fine. So this is question how this is happening. Now let's explain. See, the main factor for ring opening is the ring strain of this cyclopropane. Okay, keep it in mind. Now question how this reaction happens. So let me draw the structure again here. So this is let me write it in a different way. OH double bond. Now there is a methyl. Okay. So question how this reaction is actually happening. Okay. So you may consider in this way that it abstract. So first of all, see, this cyclopropane this ring want to break, because this breaking of this ring will release the angle strain. Okay. So where it is expected to break? If it breaks, means I want to mean this derivative, if it breaks here, what it will result? This carbocation, which is a secondary. But another way, if it break from here, it will result this, which is a primary. So breaking is preferred in this case. Okay, so that is the reason why breaking is happening here at this position. So first it breaks here. Second question, then this oxygen became negative, so it can abstract the proton here, 6 member. After that it comes here and this oxygen attacks here. Okay, I'll tell again. First this bond breaks, so positive charge created at this position. So it comes here, so this double bond open and this negative charge abstract this proton. Consequently this negative charge comes here and this oxygen became electron rich, so it attacks here in order to neutralize the charge. Let me draw everything carefully. In such cases, I always suggest please try to keep everything as it is. So this is a double bond. One is already OH there, one OH is here. This bond is broken. Fine. Now this is carbon. This is attached to oxygen. Double bond. This and this is attached. So this is the overall thing. Okay. So in this way, probability of mistake is minimized. Now let me draw it in a different way. See, it's a double bond. In all, so first let me draw everything as the exact structure. 5 member. So this is this. Next is this. Okay, this is the methyl. Now it will undergo tautomerization because it's a diol. So gem diol is not stable, so corresponding carbon will be produced. So this. So now you can consider this is this. Okay. So by the way, one confusion you may have, that sir, why this doesn't undergo decarboxylation like cis-member transition state like the malonic ester. First of all, there is a Rinston which I told. There is another point you may consider. See, this cyclopropane actually is not 60 degrees, it is around 114 degrees. It's a banana bond, means these bonds have, more p character. Okay, so if this bond has more p character, this bond have more s character. So more s character. What does it mean? If s character increases, then bond angle improves. So this bond angle is a little high. No, like for example, sp3 109 degree, sp2 120 degree, sp 180 degree. So this bond angle is also little bit higher. Another, that is a point. Please keep this factor in your mind also. Okay, so this is the reason. So now let's come to this. See, this is actually a alpha beta. So this is a beta-keto acid. So it can undergo facile decarboxylation. I forgot to give the methyl. So okay, fine. So how this happened? So this thing abstract, it comes and this it comes here. So what is the product? So the product is, this is the methyl and this is a double bond, this is a OH. So instantly it will tautomerize the corresponding, it is a enol version, corresponding double bond. Okay, so this is the overall way to get the product. By the way, one important information, please keep it in mind. When there is a group which can donate its electron pair to this oxygen, what do I mean? See, this oxygen, it could have a canonical form. Means, let me change this part. This. So, but it can push and it can come. Means, this O minus plus methyl and this is the CWH. Now, see, when there is a chance that such type of group can release some electron to this oxygen, then the reaction rate increases. Example. As an example, I can give you comparison. Means this is a beta gamma carboxylic acid. Fine. This is alpha, this is beta, this is gamma. And if you compare this with corresponding OMe derivative, means an vinyl ether, you can say. So if you consider that their reactivity, this versus this is far more reactive, because during the transition state, means transition state involves this. Okay, so this pushes electron, which helps to abstract the proton and form the 6-member transition state. Okay, so this is important. So this also you give this information, which actually is not involved or necessary for this example, but I believe you should keep this information in mind also, because what type of problem can come, don't know. And this comparison, this OMe is far more reactive compared to this. Okay, this example you also just try to understand because of this. So this part I have already discussed, that is decarboxylation of beta-keto acid. The mechanism is same. Another thing, I have already uploaded another video which is decarboxylation of alpha-beta unsaturated carboxylic acid, which also follow the similar track, but ultimately through the beta-gamma isomer formation. Okay, so this is the end of this discussion. So what we have learned? We have learned that in case of cyclopropane derivative of this 1,3-dicarboxylic acid, the decarboxylation mechanism doesn't follow the similar pathway or traditional pathway, rather than it follows another pathway where the cyclopropane ring is broken in order to release the ring strand to produce the corresponding 5-member ring derivative under, means in presence of this moderate condition like 90 degrees centigrade, and followed by a decarboxylation. Okay, so this is the overall description for this process. So I believe in such case examples, if come, such type of example took some time, it is true, because they are difficult. So very few question comes which are a little difficult, but I believe you should try. I suggest that I am trying to give you some question, you practice. If you can answer those questions in the exam hall, that is excellent. But if you feel that due to time shortage you can't attend, then don't. And another thing I suggest that keep some time, means initially prefer to do all the easy questions, answer, and later on you keep some time in your hand, save some time that such question you can attend. Okay, so in this way you can balance your time and utilize the exam time properly, such that you are trying a difficult problem for more time and wasted some time, whereas there are some easy problems which you couldn't attend. So this is the overall strategy. I believe it may be helpful for you. So thank you everyone for watching this video. If you really like my teaching, I request you, please help my channel to grow. First of all, subscribe my channel Chemistry, the Mystery of Molecule, and please press the bell icon to get the notification of every single video I will upload. Secondly, pass this video to your friends, because they may also need such kind of study, because new MCQ is getting very difficult and we should practice completely such that we can be completely prepared. And most importantly, please like the video and make some good comment, because it inspires me a lot to make new videos for you on a regular basis. So thank you, stay happy, stay blessed, see you in my next video.